Essentially, the ordinary matter is made out of protons and neutrons and electrons. In this collapse of an iron core, the protons and the electrons that make up the iron atoms combine to make neutrons.
A neutron star is an incredibly dense object. Now, if you were to take a large building like the Empire State Building in New York and compress it to the density of a neutron star, it would be about the size of a marble.
They have a very high density. And in fact, a teaspoon of neutron star material would weigh as much as 1 billion tons on Earth.
Scientists today believe that only huge stars, at least 10 times the mass of the Sun, have the potential to generate this core collapse type explosion.
The massive star generates energy by fusing hydrogen to helium. It can fuse helium into carbon and oxygen, and it keeps on going all the way up to make iron. Iron is the most tightly bound nucleus. So when a star has made iron, it's really at the end of the line, and it's ready for disaster.
The iron core forms in the last day of the star's life.
And then it becomes so massive that essentially it collapses under its own weight. It just collapses gravitationally very quickly.
It takes less than a second for the core of the star to crunch down from something about the size of the Earth to a neutron star, which is maybe 10 or 15 miles across.
But this dense iron core doesn't settle down peacefully into its new life as a neutron star.
But instead of reaching an equilibrium configuration right away, the neutron star rebounds off of itself, just as the gymnast rebounds off of the trampoline and goes upward again. Well, this rebounding neutron star collides with the material surrounding it and imparts some of its energy to that colliding material, thus initiating an ejection.
However, unlike a gymnast, for whom gravity ultimately prevails, pulling him back to Earth, in a core collapse scenario, something else continues to drive the ejection outward. The question became, what was this mysterious force driving the blast into space? Experts calculated that in order for a successful explosion to occur, one more ingredient was needed: